Welcome to the examples video for the sine and cosine rule. In this video, we'll go over an example and then do some past paper questions. Last time, in the concept video for the sine and cosine rule, we covered what the two rules are, when each of them are used, and we looked at some examples on how they are used and why we care. And to quickly recap the video, if you want to have a look at it in more depth, the link will be in the description. We'll recap that the sine rule is used when we have two angle and side pairs. So i.e. we're trying to find one of the four things, and we have there are three. Or in the cosine rule, when we have three sides and an equated angle, so we're trying to find the angle opposite the side opposite the equated angle, or when we're trying to find an angle given three sides. We'll do a quick example and then we'll go on to do some live examples of past papers. So in this example here, we're given three sides, all three sides, and we're asked to find one of the equated angles. So we're using this form of the cosine rule, and don't worry, you get given all three of the equations for sine and cosine rule in the past in your exam paper. And the only thing we need to be careful of is when we're picking what side is going to be what, the side opposite the angle has to be our a, our lowercase a, because the angle we're looking for is the big A in our equation at the top there. And we can label their two sides B and C, doesn't matter which way around they go. Okay, so let's substitute the values we've got in the example into our equation. So cos of x is equal to this equation here, where we've subbed in 6 for B, 9 for C, and 8 for the A. If you pop this on your calculator, you can do it in steps all at once, but it'll come out to be cos of x is equal to 0.49. But we're not done there because we don't just want cos x, we just want x. So to get x, we just take the inverse cos of 0.49. You pop that on your calculator and it comes out to be 60.6 degrees. Let's have a look at some past paper questions. So this first question talks about a set of step ladders. I'm going to ignore the first part and go straight onto the diagram because everything we need is in the diagram, which is ideal. And we can see that it's asking for this angle here. And immediately we can spot that we've got the side opposite the angle that we need. And we're also given another angle and side pair. And this is exactly in the form that we need for the sine rule. So if you remember the sine rule, just a over sine A equals b over sine B. And because we're looking for an angle, I'm going to actually use it in the form where the angles are on top. We're perfectly allowed to do this, so you can just flip both sides of the equation, that's perfectly fine. And I talked about this in my concept video as well before this one, if you want to have a look at that to hear about it a little bit more. But here we are. And we'll identify the angle we're looking for as angle A. This guy is just side A because it's opposite the angle A. This is the angle B. And this is the side opposite B, so we'll call that lowercase b. Okay, so let's plug all our things in. So sine x over A, which is 150, equals sine B, which is 66, over side B, which is 140. And then we want to get sine x on its own, so we're going to times both sides by 150, which basically means we bring 150 up to the other side. So sine x equals sine 66 over 140 times 150. If we pop that on our calculator, we come out to the value of 0.9788, and I'll keep lots of decimal places in because we're not quite finished the question yet, because we don't want sine x, we want x. So if I find x, just the inverse sine of the answer we've got above, 0.9788. You pop that in your calculator, it comes out to be 78.2 degrees. So that was a standard 3-mark sine rule question. Let's move on. Okay, next question here. It wants the length of xy, so it wants this side here, which we'll call z, since it's opposite the angle z. Sorry, just use a lowercase z. Okay, so the cosine rule that we're going to use is one where we're trying to find the side, so that is a squared equals b squared plus c squared minus 2bc cos a. And don't worry, you get given all the sine rule and cosine rule equations in your exam at the start of the past paper, but I've written them down here so you can see anyway. And remember that a is the side opposite the angle we're given. Are we given that angle? So we need this angle here if we want the opposite side. And we're not actually given the angle, but we are given cos of the angle, so that's all we need. You can see here, instead of being given z, the angle, we're given cos z instead, and that's all we need. So we'll identify this side here as our a in our equation. This side is obviously just a capital A in the equation. But we don't actually have a, we've got cos of a instead, because we'll identify this quantity here as being cos a. And we'll call this side b and this side c. Doesn't matter which way around we do that. Okay, so let's plug everything in we need. So we'll call it z. That's a little bit like 2 actually. Maybe we're better off calling it something else. It's fine. There we go. Z squared. I'll put a little line through it so we know it's a z actually. There we go. Equals, and we'll sub in the stuff we need. So b was 6. That's n at 8. Never mind, can't read. Plus c, which is 10. Minus, I'll put this all in brackets because we want to take this whole thing away. 2 times our b, which was 8, times our c, which was 10, and times our cos a. Our cos a here is just an 8th. So I'll pop that in. And this is a non-calc question, and that's why we've been given the cos of the angle than just the angle. And it's a little bit off the screen, let me move it over a little bit. There we go. Okay, so it's a non-calc unfortunately, so we're going to have to work everything out. So a squared is 64, 10 squared is 100, and we're going to take away, we've got 8 at the bottom and on the top, so they'll just cancel. So we're left with 2 times 10 in the bracket, so that's just 20. And so we've got that z squared 64 plus 100 is 164, take away 20 is 144. And we don't want z squared, we want just z. So z is just square root of 144, and that just happens to be 12 squared, which is ideal because that means it's not a third, it leaves it at just 12. So z is just 12. And we'll give this a box. Next question, let's keep going. Okay, so the question's asking us for the height of the hot air balloon B above the ground. So let's just mark that on here, that'll be this distance here. Let's just mark that with h. And I won't read the whole question out because all the information that actually tells us is in the picture. You can pause it and have a little read if you like, but I want to get on to the maths. And we notice it's a 5-mark question, which means that it's worth more marks than the previous 3-mark question we looked at, which means it's probably going to involve a few more steps. So we might not be able to get the answer we want straight away. And yeah, that's definitely the case. We can't just find out what h is straight away. We don't have enough information. But what we can do is, because we've got 2 angles, we can always find the third angle. And whenever you've got 2 angles in a question, you're always better off just finding the third one, just in case you need to use it. So I'm going to roll with the h now, just because it's in the way, and I'll bring it back at the end. So this, when you find this third angle here, so we can just take away both the angles from 180, because all the angles in the triangle have to add up to 180. And this is why we can always find the third angle given the other 2. And you can pop that in the calculator, set by a calculator question, or you can kind of just do it on paper. Either way, it'll come out to be 94 degrees. So let's pop in 94. And what does that give us now? Well, we can now see that we've got an angle and a side pair. That's not very neat. Let's try that again. Angle and a side pair. Oops, delete itself. And that means we can find any other sides using this angle and another side pair and using the sine rule. I'm going to pick to use this side here, and we'll call it, let's just call it A, I guess. And actually we'll call it M because it's opposite the angle A. That makes more sense. And we're going to use this angle and side pair here. So we'll try to find a side, so we'll use A over sine A equals B over sine B. And we'll try to find side A, so we'll call this, this is our A here, this is our angle A, this is our B, and this is our angle B, and fine enough it is a B already, ideal. So let's pop the values into our equation. So our A was what we're looking for, and right now it's just called M. Over sine M, and M here is 34. And the side B was 350. And the angle B was sine 94, so we've got sine 94. And if we rearrange this, we times both sides by sine 34, which just amounts to bringing it up to the other side. So we get that M is 350 over sine 94 times sine of 34. And if you pop all this into your calculator, you can do it in multiple steps if you want, but if you put it on your calculator, it'll come out to be 196.2, and I'll just leave it to one decimal place for the time being. Okay, and the diagram's got a little bit messy, so I'm going to draw it all out now, but in your exam you can just recopy the diagram out, however you want to do it. And remember, what we're looking for is this height here, h, and we've now got this side 196.2. And oh look, now what we've got is we've got a right angle triangle here because the height of ground, the ground will be perpendicular, because the ground's perpendicular to the height. And we've got the hypotenuse or right angle triangle, and we're looking for the opposite angle, which is here, which is h. And we've got an angle, so we can use our nat force SOHCAHTOA. So let's quickly sketch out SOHCAHTOA. And tick off what we've got. So we've got the opposite, because that's what we're looking for. So tick off the O's, and we've got the hypotenuse, so we'll tick off the H's, and we can see from this that we're looking to use sine. And we're looking for the opposite, so the opposite is just equal to the hypotenuse times sine of the angle. And so that means h, which is the opposite, is just equal to the hypotenuse, which is 186.2, times sine of the angle, which is sine 52. And this brings us out to h having a value of 154.6. You put that on a calculator, and the question's in meters, so we'll put it in meters. And that just involved two calculations, the sine rule and then a basic application of SOHCAHTOA. Cool, let's keep going. And this next one's only 3 marks, so it should be a little bit less work. So it wants us to calculate the length of the fence QR, which is the long side here. Let's just call it P since it's opposite the angle P. And we can see that we've got two sides and an included angle, which is exactly the form of using the cosine rule. And I'll quickly write it out again. Don't worry, you won't have to write this out in your exam, you can just copy it off the equation sheet, but there we are. And this is side we want, and this is opposite the angle we've got. So we'll call this A, because it's the one we want. We can call this one B, call this one C, doesn't matter which way down we do it. And our angle here, P, is the angle A. So sub it in, P squared, P is the thing we're looking for, equals B squared plus C squared, so 180 squared plus 250 squared, and this will be the calculator question, because there's sine of angles involved, so we can pop this in our calculator, so don't worry too much. Anyway, take away everything in the bracket, so that's 2 times B times C, oh, moved over by accident, that's fine, 180 times 250 times cos of 147. And if you pop that on your calculator, we'll get a value of P squared as being a quite a big number, 170,380.4. But remember, we're not looking for P squared, we're looking for P, looking for side P. So P is the square root of this guy. I won't write it out actually, we'll just say it's the square root of this, which is 412.8. And the question's in meters, so I'll leave it in meters, and I'll zoom out so you can see the whole question there. There we are. And that was a trivial kind of example of cosine rule. That was a selection of a few past paper questions. If you want to look at this topic a little bit more depth, go back and watch the concept video on this. I hope you found this useful.